The other reaction we're going to look at here is called the acetoacetic ester synthesis. And this is almost identical to the malonic ester synthesis, except we use a slightly different starting material, but the process is going to be the same. Alkylate, do the hydrolysis, decarboxylate. So the main difference is in your starting material, we use acetoacetic ester. So instead of having the diester on one side, you have a CH3 group. Right, so in this case, let's just say we want to add at that alpha carbon, I want to add a CH3 group, and let's add an allylic group. Like that. So those are the two things we want added. So the process is going to be pretty much the same. First, we'll add our base. Followed by, if I want to put the methyl one first, I'll use methyl halide. I'll just use the bromide here. So that'll put the methyl group on. Now, if we want to add this allylic group, we need to do a second alkylation. So I'll add the base again. Here's the allylic bromide. The bromine's not directly attached to the double bond, it's attached to a CH2 that's next to the double bond. So now we have the methyl, and then we have the CH2, and then the double bond. Right, from here, we can do the hydrolysis and decarboxylation all in one step. I'll just go ahead and break it down into two. So if you do it in two steps, add acid and water, that'll hydrolyze the ester to the carboxylic acid. It doesn't change what's attached to the alpha carbon. And then from here, when you heat this, then you lose that carboxylic acid as CO2 gas. Here's the methyl group and the allylic group. Again, if you want to be a little more straightforward, you can do all of this at once, like that. Now you might recognize that this is something you could have made using some of the other reactions we've learned, where you could have started with acetone and then just did a direct alkylation and put the methyl group on and then the allylic group. But this particular pathway tends to be very high yielding. So we'll say this is an alternative to the direct alkylation. Okay, now if you want to review what the direct alkylation is, I will quickly walk you through that. If we want to make that same product through the direct alkylation, you would start with acetone. From there, you could do something like LDA, and then if you want to do the methyl group first, we could add methyl iodide. So that gives you this product, and then to add the allylic group, we would need the thermodynamic enolate, meaning you would want to use a base like hydroxide or ethoxide. And that would give you the thermodynamic enolate at this position. You would then alkylate. And you do get the same product we got through the acetoacetic ester synthesis. But this protocol tends to be lower yielding. And the main reason for that is because in this case, we have these alpha protons that aren't quite as acidic as the alpha protons in acetoacetic ester. Because these protons are much more acidic, we get a much cleaner alkylation specifically at that position.